Good morning. First of all, I'll introduce Mr. Niranjan Palekar. He is Bachelor of Engineering in Mechanical Engineering. So he is mechanical engineer and he is doing civil work. That is more appreciable. Last 5 years, he has done EPC of various types of biogas plants. He has worked with Kanere sir and he has done biogas plant with ferrocement technology. He he has managed and run biogas purification system for various scales. He has done domestic work as well as industrial biogas plants, and he has done all over India. He's worked all over India, and he has also done various types of construction in ferrocement technology. He has worked with Kanara sir, and he has done that residential bungalow also with ferrocement technology. I'll request him to make his presentation.
Good evening to all. Um, as Lele sir introduced me, my name is Niranjan Narayan Palekar, and basically I'm not from the so-called civil and expertise field because I work in the under guidance of Mr. Deepak Kanere, who is a stalwart in biogas and all areas regarding the gas purification system. But our problem was that for the construction of any how digester or for the construction of any civil work what we are going to construct, that the cost affect us when we are talking or when we are marketing our product in any market or in any culture. Then I'm having some product, or if I'm having a prototype in our hand, then it will be better to convince some people in our market. So let's start. Our firm is Sayujya Urja Private Limited. It's based and in Nanded city, Maharashtra state. Basically, we work in ferrocement technology with the help of ferrocement technology basically, but we mainly work in biogas field. But for the biogas digesters and or any other civil shapes, we use this ferrocrete technology. You can see in the picture, we have constructed a check dam, swimming pools, anyhow digesters, and the first photo is G+1 slab. This slab is under construction in Nanded city, which is our ongoing site. You can We can go to next slide. Now the question comes arises, before 2 or 3 years, this is the site marking of our office at our company site. This is the digging or you can say foundation. The question arises in this photo or in this site that two people came to us and said that you have to dig or you have to construct a site for office anyhow. You can you must dig to 4 to 5 feet for MUROOM level or say hard strata. But our guidance and our confidence on low weight and high strength to weight ratio ferrocement technology says that we don't need anyhow that strata, or we don't need to dig that so much, because ferrocement is so much light in weight, so it can sustain anyhow. And Divekar sir said once that the water ratio or water problem has to be solved out. Then you have to dig some sort of piles around the circumsurface. I say in about 25% of cases that some of houses will have to be constructed on expansive soils, and we live in a such a area that black soil is up to 25 feet somehow in some areas, but it's a 10 feet below the ground in average areas. So light structures are more prone to the development of cracks, I feel, in such soils. So if constructed on that shallow plinth beams and in that in expansive soil, it is necessary to provide that under rim piles with the plinth beams above the ground level. So I am not having that photo. After that, we have done is we have dimmed a rig around the structure. So anyhow, the excess amount of water is come out. So the water can go and pass away that under plinth beam level. Then coming to the next slide. So this is the wall skeleton of our office suite. What we have done is we have used a 1.5-inch square hollow pipes. You can see the it's a 400 square feet area. It's a carpet area is 400 square feet, and after that we have extended. For this side, we have used a center column and a center pipe of height 12 feet. It's a tapered roof, so you can see 1.5 feet is a plinth area. After that, we have plastered it in such a way that it can sustain a extra excess heat in a western area. We live in a Nanded city, which is comes in Marathwada region and has a temperature of say about 45 degree to 48-degree max in some cases. So what we have done is we have used thermocols in western area walls. Uh, Due to this, that thermocol comes into the cavity wall region. So only our one wall is a cavity wall. Say suppose a 1-inch thermocol and the thickness of our wall is 2 inch, so it becomes 3 inch or 3.5-inch wall. What it has done, it has a very measurable temperature differences what we felt when we were living in that house. So the one wall is thermocol insulated, and the next slide, it's a slab skeleton. You're seeing that the 1.5-inch square hollow pipe is there. There is 8 steel bar which is welded in the spacing of 6-inch by 6-inch, and the three-layer hexa meshes were wound together, bindly together and tied by the masons, trained masons. We have a very trained team members of 8 masons and 5 laborers, and our team is such a planned and such a well-made in a manner that the team members itself can train any person in world. You can see now we have filled the murum up to the plinth. So basically, this is the you can see the window feet by 4 feet by 6 feet. On the right side, you have we have a sit out area, and up to the plinth level, up to the lintel level, we have plastered it. The whole construction process has carried out in a 40 to 45 degrees Celsius temperature. So that green shade net should be there for our work. Next slide. Now this is the final plaster and final picture of that house. You can see what I was talking, that wall in the western area, the wall, you're seeing the pipes on the wall. That wall is insulated with thermocol, and if you've gone to that site and just press just touch the wall, you can see or you can feel the difference of temperature variation from thermocol wall and from the other wall, because it has a cavity wall. So it gives a very much, I said 4 to 5 degrees Celsius temperature difference, and it has a good advantage of that. And based on this experiment, we have carried out this thermocol experiment on 2 or 3 sites. Rather than in next slides we can see that. So this was our first and only small scale house in ferrocement technology. Apart from that apart from that, we have constructed some sort of bathroom and toilet. Now, why this come up, we have already bathroom and toilet over there, but there were whole scrap of steel and pipes which is left from the house skeleton. So we decided that from this scrap we have to build something, and there is that it thing came up, and we have built it, that wall, from the scrap of that house scrap. uh, this is our labor shed, which is 15 by 15 feet and 12 feet height. There were This is also same case of that scrap. We have so much scrap on our side, or the left out scrap from our other work. So we passed out on our side and constructed some labor rooms, so that we can say that it is very so much economical in our way and some time consuming. Now coming to the geodesic dome part, your part is showing that it's a pentagon. Basically, I'm showing the final picture and coming to the first picture. So this is the final picture of that geodesic dome. You're seeing that there are some pentagons and there is some equilibrium and bilateral triangle. Now coming to the first picture, there are some pentagons in the geodesic dome. There are 10-degree outlination and 10-degree inclinations of every pentagon, and the problem is that after you made after you welded that skeleton of that pentagon in a such a way that the center of that pentagon is 1 feet upper to the ground, the problem arises that when you don't have such much so much knowledge in that field and just say that I can do it. But what I have faced the problem is that while arranging that pentagons in a such a manner that each one is 10-degree apart from each other, and between those two pentagons you have to make a bilateral triangle. And you can see the triangle above that labor hand it should be a equilateral triangle, and the triangle below that labor hand it should be a bilateral triangle. Unless and until that 10-degree inclination is not mentioned or 10-degree inclination is not managed, the apex will not match. So our problem was that apex were not matching. So due to lack of knowledge in perspective field and in implementation of that structure, we have faced some this type of problem. And literally I'm saying that I have to make that arrangement twice, and the final result was that you can see the apex is matched due to that pentagon has been arranged in a such a way that upper layer of triangle will be a bilateral as equilibrium triangle, and the lower layer of triangle will be a bilateral triangle. Unless and until you make arrangement in a such a way of that inclination degree of that pentagons arranged in a such a way, you cannot make it to the center. And why I am telling this technically detail, because due to only and only ferrocement technology of that welding tool or tying rod or meshing, I cannot make it happen. You cannot make it by only brick work, or you cannot make it by only pop work. You have to sustain or you have to stick it to that one and only ferrocement technology. So we have made arrangement of 7 feet and 2.5 feet wide door arrangement, and after that we have made two windows on that geodesic dome so that the wind can pass out. You can see the final picture. So this is the final picture of that geodesic dome. Now you can see that pentagons, some hexagons, and some triangles. All are equilateral triangle. All are the sum of equilateral triangle, some bilateral triangle. So basically, this is the geodesic dome, which can be only easier to make and construct in ferrocrete technology. Going to the next, this is the G+1 slab. Basically, that this site is located near Nanded city. This is the phenomena or the process carried out before that slab. It's such a way that we are going in the market and we don't have any product. Unless and until we don't have our own product, you can convince the other people. What I said that. So because of that, when we're talking to the people that you can construct your own house in ferrocement technology, you can construct even G+1, G+2, and G+3 house in ferrocement technology. So people were asking me that have you constructed? So I didn't have any answer. So why not we make our own shape? So we decided that we have to build it, and we have to prove to the people that on ground house is possible own and one and only by the ferrocement technology, even though G+1 is also possible by the ferrocement technology, because we live in a such a area that people has to show something before. Unless and until you have it, people will not believe it. So we have decided to construct it. So by step we are going through. This is the process what we have carried out. Basically, you can say that only all of our stalwarts in this ferrocement technology. So there are various mistakes what we have done and what we have faced in our fieldwork. But I believe that one should have learn from the mistake. Sorry. So we're talking about our G+1 slab. So we have packed that this beam in a such a way that it should have a welding mesh. It should have 6 mm tall tor bar, and it should have triple layer of hexa mesh. What we have done experiment in this casting of beam is that we have poured concrete in a such a way, and that we don't need any plaster after casting. So I don't have photos of that after casting photos. This is the first initial photo what we have done firstly for due to before casting that beam. uh, the major point is shown to be is noted that we didn't use any of 8 mm, 16 mm, or any of bar which is greater than 6 mm bar. The whole element, the whole G+1 slab and column and beam and already always every aspect of element of that structure is casted, it's constructed with only 6 mm bar. We have welded it, we have casted it, and we have made it possible only 6 mm bar. Now going to the next side, it's a plinth plaster. You can say that now you can see the columns are standing up, and this is one and only 6 mm bar. Now for the left side, you can see the other columns which are which were welded, and after this column casting and after this beam casting, we have certain team, and we have our friends crane. With the help of crane, we have casted and we have make it possible to the 15 feet above welding. Now coming to the supporting part, these are the fins for our slab. Everyone asks that how is it possible that 2-inch slab is going to the sustain. So we say to them that come and see, you can and we can. So these are the fins which are 8-inch long, and apart 3 feet apart from each other. Actually the fins were casted, and what we have faced and what we think now, actually the fins should be pre-casted on other side, and you should be lifted from that company side or the civil side. So it will save your time and what we have experienced it and what we have concluded from our work. So this is the side view of beam placing. After that beam placing, we have casted that supporting beams and fins. This is the picture of first casting of fins. So you can see that first we have casted the supporting fins, and after that we have casted that beams also. And all of beams and all of our columns are casted in such a way that it has a layer of 1 inch by 1 inch welded mesh, and it has a layer of 3 layers of hexa mesh. Welding mesh has a layer, has a gauge of 12 gauge, and hexa mesh has a layer of 20 to 22 gauge. Actually what we observe that concrete is also strong in compression, but what we all know that it's weak in tension. So for that purpose the steel is introduced in the concrete, so that there should be some elasticity or there should be some tension sustainability. But this combination of that concrete with the steel cannot be converted. It cannot convert concrete into elastic material. So what I think, this can be done by say pre-stressing of that material. This can be done by say introducing some fibrous material into that structure. But what I feel, it can be easily and economically done by the ferrocement technology, by introducing some this hexa mesh and welded mesh. So we have used that 12 gauge welding mesh, and I can confidently say that by using that welded mesh, we have made such a result of that beam and and columns, that it is very far much better in compression and tension strength. And basically, this was our mistake. When one should have proper knowledge on casting side, but we don't have that much of knowledge during casting of any beams and supporting a housing field, so the fins were distracted. So our you can see that our labors are going up and matching the mismatched fins by cutting or welding and pre-casting. So this is the one-way slab what we have casted in one day. You can see the whole skeleton is welded. The whole skeleton is welded with the welding mesh and triple layer of hexa mesh, and this whole work is done in a one day, and a 2-inch layer, and a proper cement ratio of 1:2, and water cement ratio at 0.35 to zero point 0.6 something. Now you can see this is the final plaster. After plaster of that slab, you can see some fins supported by beams and columns. This is the built-up area of 1500 square feet and a carpet area of say about 1200 to 1250 square feet. This is the whole view of that column and beam G+1 slab. Now coming to the next point, this site is constructed in Nagpur area. Now this has some sort of issues while doing that site. We have gone there for another work, but that owner of that farmhouse has said that there is some problem for G+1, for that ground level slab, upper level slab. So he said that, and he came to me and said that there is some problem, and that my wall, G+1 slab wall, cannot sustain overweight. So what is their solution for roofing or for the slab? So I have said that we have our confidence, and we have ferrocement technology which is low in weight, high strength and weight ratio, and it can sustain easily with your load bearing walls. So we have started working. uh, what we have done is the same way. The 6-inch by 6-inch spacing is done in 8 bar, and 1-inch hollow pipe is there. Somehow we have used 1.5-inch for edges and 1-inch in between these areas. We made it happen that only 3 feet by 3 feet, or 3 feet, say about 3 feet by 2.5 feet square should be there, so that there should be no elongation or there should be no bending in that area. There are sufficient columns and there are sufficient load bearing walls, so that the whole structure weighs about 1.5 tons something, but it can sustain all above before casting of that ferrocement due to the welding of that steel. So if and you can see one another option, that we have used thermocol in this slab for insulating purpose. Actually, I said that this site was in Nagpur city, so the Nagpur city has temperature range of 45 degrees, say about somehow 46 or 47 degrees Celsius, which is very far much hotter than any house area. So there should be some insulating techniques while constructing. So we have experimented it, we have practiced it in our company site for our first site. You have seen that in our first site we have casted the thermocol in the western side wall, and the same way we have used it in such a way that the thermocol area should be in between these two layers, and above that thermocol we have used some again a 4 bar and again a layer of hexamesh. So there should be a minimum covering of 10 from each side, and it has a weight say about something 2.5 ton. But but principally talking, there is a uniform load distribution of say something 200 to 230 kg per square feet. So this is far enough, what we can say in our thumb rule. And this this is the final plaster and final finishing of that slab. We have done such a arrangement of that fins, and in arrange that fins in a such a way that it should be aesthetic also. It should it should support the slab also, and come into the picture that it should attract also. So this is the beauty of ferrocement. You can manage it, you can arrange in that supporting fin in such a way that you don't need any POP, or you don't need any aesthetic in our home. So this is the basic upside down view, and this is final view, and this is, let me see, that is the final. And our aesthetic architecture engineer is also taken that purpose in a challenge way, that he has arranged in a such a way that fins should not be get distracted, or fins should get not be dislocated. So thanks to them also. Now coming to the next point. Now my last work in last 6 months is that we have constructed a septic tank in Aurangabad MIT College. This for 12 persons, and the owner of that land has said that that we work in a biogas field. So we have expertise in any gas accumulation purposes, and we have expertise in gas proofing and waterproofing of that percolated structure. So we have made that septic tank in a such a way that the gas which is come out from the septic tank is accumulated in a balloon and can be utilized in a cooking purpose, for cooking purpose. Anyhow, that gas was not so much amount in amount, but we have made it septic tank what we have made. And the next one is the upper layer of that covering for that slab. There is a manhole missing in that photo, but we have made it a manhole in next photo. I don't have that photo right now. The septic tank has its own cover, but due to the ferrocement cracking technology, we have waterproofing solution, we have a low weight solution, we have so much number of uh, high in compression, high in tension applications that is we are using and we will be using in your future. So this is it. This is my last PPT, I think. Yeah. Thank you, everyone.
Thank you, Niranjan.
Pardon me, sir.
Thank you for your nice presentation. Yeah, you have done a lot of work. So I'll ask Milind sir to comment on it, and also I think Mr. Savio is also there. So first of all, I will ask Mr. Savio.
I think the slabs very beautiful and very simple to building.
Right.
And about the biogas, Mr. Palekar, you can capture the biogas and take out the biogas. Thank you.
First of all, my compliments to Niranjan Palekar, his father Narayan Palekar, and Anari sir for doing an excellent teamwork and excellent confidence in doing such works. And there are very few people in the field of biogas. I have been also coincidentally working in the field of biogas, but very large biogas, more so on the civil structural side. But let me come and thank him for doing an excellent job and having great confidence in doing the trials and errors. And I don't think he is a mechanical engineer. We will call him a composite engineer because ferrocement is composite, so it is made up of mechanical, civil, electrical, and everything. And then that engineer, so he's a complete engineer than most of us who are civil or electrical or mechanical. That is composite engineer for composite.
Thank you, sir.
So
Thank
that's
you.
excellent work.
Thank you.
But coming to his problems, I will go point by point.
Yes.
The first important point is the foundations, because I am myself doing a lot of work in Latur, Osmanabad, Bid, and Parbani. And in fact, at Yerandeshwari, you must be knowing Parbani.
Yes, sir. Yes, sir.
In Purna Taluka, we are building a spinning mill now. Jay Bhavani spinning mill for MLA Dr. Dr. Patil, Rahul Patil. So that's a very large spinning mill. It's about almost 25 meters span and 250 meter long, plus other multiple things. So the black cotton soil issue has also come up. But in our case, we need not go for underground piles at all, because there are simple techniques. You just can excavate up to say 1 foot or 2 foot, and you remove all that black cotton soil and mix it with lime. And there is a small laboratory test to decide how much lime to be added. Once the lime is mixed, and it is in Marathi it is called ghana. Actually, you mix the lime with the cow at the at the center, and completely after mixing the lime helps in reduction of the expansion of the black cotton soil. So you have to add a appropriate amount of lime. It is simple chuna in our Marathi. And once you add that lime with a small amount of water, the entire expansive property of black cotton soil gets neutralized. The same black cotton soil, you have to lay it on the soil and roll it or ram it and use it as a foundation. Put normal bricks on that and put some sand filling on that to just to take care of some lightly expansion from the other sides. So just 300 or 350, 400 millimeters, 300 millimeters of sand filling, and then you can do ferro PCC, and then you can do the foundations and be done with it. So that is the foundations. You don't need underground piles.
Absolutely.
Key point is that lot of black cotton soil is there. You cannot afford MUROOM. MUROOM is very expensive and comes from very far areas. So MUROOM is a big challenge in Marathwada district. So the same black cotton soil can be used with lime addition and filled in the plinth also, where large quantities is required. So you can excavate somewhere and use it. That is first thing is about foundations. Second is the, as I said, the sand filling, and that will probably be solved. And most important is, of course, as far as the heat reflection is, as the pipes are concerned, the pipes appear to be very large in diameter for ferrocement. You could end up seeing some cracks when the pipes are 1.5 inch you are using for fabrication. I think you must certainly avoid using very large diameter pipes. Though you are using 6 mm bars, which is a very, very good thing, and that is the correct thing to follow. But closer spacing of bars and something to let the skeleton stands on its own, but avoid the pipes, because pipes are very large diameter and you might see some cracking later on at the location of the pipe.
Yes, sir.
So that is one thing.
Yes.
As far as heat reflection is concerned, there are heat reflective coatings available, which are they are called the solar reflective index. Anything above 85 solar reflective index is a very good protection coating from the outside. And even our thin walls of 25 millimeters, you can coat the walls with 2 coats, and you have very strong protection coating, and the inside temperature, outside temperature, there will be minimum 10 degrees difference. So it is a very good thing and very simple thing to do. Otherwise, there is another alternative. In the mortar itself, you can use ceramic balls. The ceramic balls are ceramic spheres actually, and ceramic spheres are very, very good, having good quality of heat reflection. So those if you add, then you don't need to do any coating also from the outside. So that mortar becomes heat resistant. So that is a great advantage that you can use in such areas. So that was what I was saying. And most important, we should get away with the underground piles, because that's a big problem. And we should tackle the black cotton soil by adding lime, and adding an appropriate amount of lime, and add water and mix the lime and make it a proper mix, like you mix cement and sand. We make a proper mix and use that sand, that same this thing, and put it back in the foundation level. Strengthen it by packing and ramming it, and then put a brick layer on it and put PCC, and then you can put your ferrocement walls. So that will certainly be a very good change for you, and you don't need to rely on underground. That is all I have to say right now. But excellent work. I'm very proud of you. And another important thing is regarding the methane gas. Methane gas is extremely corrosive to concrete or mortar.
Yes,
It is extremely corrosive. I have recently, about 5 years back, repaired and restored 16 domes in Yashopur in New Delhi, and each dome is about 40 meters diameter. It is 40 meters diameter. We broke the domes because the domes were completely damaged by methane gas. And after redoing the domes with proper mortar, with proper admixtures, the underside of the domes where the methane gas comes and hits, there we have coated with ceramic coating. Ceramic coatings are extremely powerful to take the challenge of methane gas, which is also extremely powerful to damage concrete and mortar. So you can use ceramic coatings in domes where you have biogas, and it can work extremely well.
Yes, sir. Yes, sir. Definitely, sir.
Yes, sir. Thank you very much for your inputs.
Thank you.
You have done very valuable inputs for others. And now, Mr. Abu sir, please your comments, please, sir. What you are doing in Bangladesh?
Actually, in India, you are doing lot of work, but in Bangladesh, actually, we have just started working on ferrocement. For last 40 years, we have only what we have done with ferrocement is the particular size of overhead water tank. So the water tank is ferrocement water tank was very much popular in Bangladesh, but again nowadays people are not using that ferrocement. So not because of ferrocement is not good, but mainly because actually earlier there was a single house with its 1, 2, 3 family. So one particular model of water tank was popular, but when developers become in the scene, and in one plot there are 20, 30, 50, 100 apartments. So the requirements of the water tank is very big, and we could not actually, the design engineer, we could not accommodate the bigger size water tank using the ferrocement technology. So it is our professional engineers' fault actually. We could not keep the concept of water tank and underground water tank. So now regarding the presentation of Niranjan, it's I must say it's a very good work, and as Milan pointed out a lot of things, and he also. But one thing I was not very clear regarding the roof slab of the house. So some ribs are 50 millimeter thick, and maybe instead of beam just directly from column to column, that was more thicker, I think. So what was the thickness of those ribs?
Mr. Niranjan.
Yeah. So
sound is not audible, sir.
He's asking.
Actually, I could not catch you regarding the ferrocement roof slab. Yeah. So that was the rib slab. It's not rib, but it's better to say it's a waffle slab. Yeah. So the rib thickness was, as you mentioned, 50 millimeter. But directly from one column to another column, that rib looks thicker, yeah, more thickness more than 50 millimeter. So what was the thickness?
It should be sir 50 mm throughout the work, but due to some lack of our team workmanship, it has gone some up to 65 mm.
All ribs are 50 millimeter thick.
Yes, 50 mm. Okay. Somehow, due to some lack of workmanship, it should be gone something about 65 mm.
No, that's not
Indian labors.
My idea was whether all ribs are having same thickness or some
Yes, yes.
main rib and secondary rib are there. So
No, no,
no,
no. The
no
all
such
ribs,
all
all
ribs
ribs
are
are
of
of
same
50
thickness.
mm. Yes, sir. Yes, sir.
So and another actual issue I could not also this is the regarding the applying this mortar. Yeah.
Yes.
So you did not go for any shuttering. Yeah. It's
No.
any support. So
No.
how you have casted this roof?
There are, while casting the slab, there are some temporary shuttering for the slab, but while casting the beams and the columns, we didn't use any shuttering. As we had told and just seen out that there are welding mesh covers and 3 layers of hexa mesh. So what happened is that when we pour concrete in that beam, the concrete tends to pull out and tends out. So while that 3 layers of hexa mesh and that 1 inch by 1 inch weld mesh stops that concrete from outing. So you can just finish it off, so you don't need any plaster regarding before after the casting of that beam. So this is the advantage of that casting.
No. So
You don't need any shuttering.
you applied mortar from the top. Yeah.
Yes, yes, we have poured it from the
And
top.
there are temporary support from the bottom. Okay.
Temporary support, temporary support.
Then
After 1 or 2 hours it has settled down, we have removed that support.
okay. Then later on you have finished from the bottom. Yeah.
Yes, yes, sir.
So and in addition to that, whether you go for plaster or no.
There are some 4 to 5 beams which are casted perfectly due to our labor team, but due to our lesser workmanship, we have casted 3 to 4 beams after the casting of that beam.
So
But
you
it's
have used
better.
any,
Yes, sir.
you have used any admixture with for your mortar
There are some
or
waterproofing.
cement and sand?
There are some waterproofing elements while making the concrete mixture. So the nominal water mixture is what we are used.
No, actually, I just whether you add some water reducing plasticizer or something like that. No.
No, no, no. We have used general purpose like Dr. Fixit. This is the
Oh,
general use waterproofing element. What we
okay.
use in concrete or what we use in plastering.
Oh, so you used waterproofing element, not
and
water.
one more, sir. And one more, sir. As I had told that the concrete is weak in compression and strong in compression but weak in tension. So this can be overcome by due to pre-stressing of that element or by with the help of ferrocement technology. So with some casting of somehow beams and columns, we have used some fibrous material like
Okay.
banana fibers.
Okay. Another thing is the rib was a 50 millimeter thick. What was the depth of that rib?
8
What was
inch,
the
8 inch,
8 inch?
200 mm.
So you have checked the you see slenderness of that rib. Is it okay? The slenderness ratio of the rib is okay or not? Whether you have checked it or not?
Uh, we have not checked the slenderness ratio of that bits.
But what they have ensured, they have indirectly ensured that by placing the beams at 3 feet center to center
Yes.
and making a proper grid, they
Yes.
might have not designed it for that, but indirectly they have designed it by placing the grid at 3 feet grid. You know, a 3 feet grid might have saved them from the beam being slender.
Okay.
Because normally the beam would become slender if you make calculations, but they have cross-braced it at every 3 feet in both directions. So it's a 3 feet by 3 feet grid. So that is why indirectly they have ensured that it is not slender.
Okay.
Yes,
So
yes.
Indirectly, yeah.
50 millimeter is okay.
Yeah.
For 3 feet by 3 feet openings. Okay, it's a thank you very much. It's a very good. I must say, it's very good work. The very difficult part is actually to apply the mortar and to compact the mortar. Yeah, that is a very difficult job. So we need actually trained mason, expert mason to work
Yes.
in city.
Yes, sir.
Okay, thank you very much.
Thank you, sir. Thank you.
So, Mr. Owen, your comments, please. Are you there? I think he's not. Divekar, sir.
No, please unmute.
Yeah. Hi, Niranjan. I found it inspiring, the scope of your work and the linear aspects are coordinated very well and worked on very well. And I think that my approach to ferrocement is far more radial lines and using the radius for strength or the ellipse for strength, and sometimes use, let's say, lineal beams that are precast to use as part of the formwork for the arches. I noticed one beam in the beginning of your presentation. It was like a big header across an opening.
Yeah.
That was extremely large and I believe heavy with metal, iron. Perhaps internally an arch could have been made it much stronger.
Right.
An internal arch that you wouldn't even see from the outside, even if it was only the steel was arched. That's my opinion, but of course your work is inspiring and well done.
Sir, that arch is an excellent idea, but that arch would lead to a lateral thrust on the columns. If the arch were to be placed on the columns, and
landing on the column.
Yeah, the arch would lead to a lateral thrust on the columns. That will be a horizontal force will be applied depending upon the riser of the arch. The shallower the rise.
Push out, you mean.
Yeah. It will push the columns outside. So you need a tied arch. It's internally what we call as a tied arch. So the tied arch solves the problems of the lateral load that comes on the columns at that point. And the columns,
I could see that. Yeah.
So you can have a tied arch. That is a good idea.
Anyway, that's my opinion, and again, inspiring scope of your work.
Thank you, sir.
Divekar, sir. Can you comment something and give guidance to him?
Congratulations, Niranjan. Congratulations. You said that you have worked only for 5 years. You have done such a wonderful work that we people with all the experience and all the taking our scholarly attitude and all that and studying all the books and doing so many things, we have not done in 25 years. That we have achieved within 5 years.
Yes, very true.
Without any background of civil engineering about the stiffening, as you have said, that we have put the stiffeners or say the grid of beams with the slab, that you have indirectly converted that slab and that beam, it becomes a T-beam. And as you have placed the beams and the ribs at 3 feet center to center, it has become a grid of T-beams in 2 directions. That is a wonderful, and that you have learned through experience. You have not made any calculations. That is what is the wonderful part of it. Also, the second mention, which I appreciate, that you have provided thermocol on western side of the wall. That is very, very appropriate thing that you did. But one thing, the next time you have provided in roof, because all the heating that takes place is from about 10 o'clock to 4 o'clock, and that is in the roof. So you have provided thermocol in roof also. That in that case, you would have definitely noted that the temperature difference is tremendous. Cavity wall itself is a thermally insulated wall, and in that you have put in thermocol. That is an additional thing. Also, what I have seen, or what Kanire sir has told me earlier, that you have made the column, central column, or in the house, whatever columns you have provided, you have made it at intersections of walls, particularly, they were in shape of T columns. They were
Yes.
not rectangular columns. That is what he has told me.
Yes.
That means a wall coming from one side and the other side, they are intersecting and in the figure of plus, say, plus sign.
Plus.
And
Yes.
that you have introduced as a column. That is a wonderful idea, very good idea. Nobody will think of it that we can have a column of a shape of a plus sign. That is very good idea. And if you consider the area of that column is one aspect, but the stability in both the directions, because you have provided in longitudinal direction and at the cross direction also. That plus size column is very important, giving stability in both the directions. That was a very good idea. About under rim piles, Kulkarni sir has already told you that lime stabilization, or in some cases cement also can be used for stabilization. That is one of the solutions. But in earlier, Kanere sir has told that to bring down the water table, he had dug some pits by the sides, which are having below the ground water table. That is also one of the important. You people have learned from experience of your own practice, that you have learned so many things that which cannot be learned by anybody by reading a number of books. So I congratulate you, and I am proud of you that you are doing so wonderful work in forestry.
Paransu sir, do you want to say something?
No, no. I just want to say whatever these practical things people are doing, that must reflect whenever you are doing all this with code and all this. If it doesn't reflect, then it's of no use.
Right.
Technically, we are using strength and shape. Like he is using a geodesic dome. We don't have to go for a geodesic dome because it is very complicated. We can go for a conical dome. A conical dome is excellent. Conical dome is simple to build. Conical dome is a compression. If we can use a conical dome instead of a spherical dome, then Niranjan will be very happy to fabricate it. It will be the easiest thing to fabricate. So there are small changes that we can make in his design and thinking that will make things very easier for him. And at the end, quality work is done. And our concept of press and fill, where he's doing cast in situ or precast, we have to encourage him to understand the advantages of precast so that the quality will be assured. And we will get thicknesses of 12 and 15 millimeters, which Lily sir has done experimentally, which AK Jain has done experimentally. 8 mm thick, 12 mm thick, 15 mm thick. That is the real ferrocement. All of us are now getting used to 50 mm, 40 mm, 30 mm. Let us go let us push the envelope and be a little brave and come to 12 mm and half an inch thick ferrocement, and still it stands. Then let's see what happens to that magic.
All of you, thanks for attending our Ferro Talk 20. Okay.
Thank you.
Delhi. Bye bye.
Thank you, sir. Thank you, everybody.
Okay.
Happy
Thank you.
they live.
Thank you.